Jai Jagannath, I am Pinaki Priyadarshini. Welcome back to my YouTube channel. In this video, we will discuss Class 9 Physics Chapter 7 Motion. This is part 2 video of the chapter. In part 1, we have discussed about distance and displacement. Rest of the chapter we will discuss in this video. Yes, in last class we have discussed till this slide. So now we will see what are the results we found from the definition of distance and displacement. Okay, so here some notes you should remember. Distance always greater or equal to displacement. Displacement can be 0. Remember, displacement can be 0, but distance cannot be 0. So let's discuss about those nodes in cases. Here in first case, as you can see, here is a person. He started walking from point O. The value is 0 here to D. As you can see, to D. Again he returned back to E, right? So here, as you can see, if I calculate the distance, what will be the distance here? So distance would be, first he covered 100 meter distance, then plus 50 meter distance, then again when he returned, he covered 50 meter. So total 200 meter distance, right? Let's talk about displacement. So from O to D, the displacement is 150. As you can see, the displacement is 150. From point D, he returned to point E. As you can see, so here the displacement would be negative 50 because he is walking in negative direction, right? So displacement would be 100 meter. Clearly you can see here distance is greater than displacement. So by case 1 we have proved how distance can be greater than displacement, right? In next case we will prove here how displacement is equal to distance. As you can see, OD, one of the person here started walking from point O to D. So what is the distance? Clearly this is 40 meter, and displacement, final point is 40 as I have written here, and the initial point is 0. Hence displacement also 40 meter. So we found that distance is equal to displacement. So note 1, this is the proof for the note 1. So let's go for the note 2. In case 3 we will discuss how displacement can be 0. Here the person is walking from A to B. Again he returned from B to A. Okay, so here the initial position is A. Again the final position also A. So displacement would be final position minus initial position, right? Final position or final point minus initial point. So final point is what? 0. As you can see, A is the final point as well, minus initial point. Initial point is what? 0. So displacement is 0. In this way we found that displacement can be 0, but distance never be 0, because to acquire some distance you have to move, no? So distance never be 0, right? So let's go to the next slide. Again, motion are of two types. One is your uniform motion, another one is your non-uniform motion. So let's see what is uniform motion. The definition of uniform motion is if object moves equal distance in equal time interval. Okay, then that is called uniform motion. So what is the meaning of the definition? As you can see, here is a person moving 1 meter in 5 seconds, again 1 meter in 6 seconds, again 1 meter in 7 seconds. So here the gap of the time is 1 second and the distance is 1 meter, right? So in a uniform time, it is covering uniform motion, right? So here this is called uniform motion. But if you will go for as it is exist in practical or not, no, it is practically not possible, because when we are moving on a road, we will face traffic, there will be highway, there will be villages, okay, there will be speed breaker. All these things we are facing while we are traveling somewhere. So uniform motion practically impossible. You need to know. Practically possible motion is non-uniform motion. Non-uniform motion is just opposite to the uniform one. So if object moves on equal distances in equal time interval, okay, then that is called non-uniform motion. It means if someone moving from A to B, okay, someone moving from A to B, the distance is like 40 kilometer. If A is a place, B is another place, and there is a person X moving from A to B, so he takes 1 hour. Another person Y, he takes 2 hours. So same distance, they are covering same distance, but the time intervals are different, right? So here we can say when X was moving, at that moment maybe traffic jam was not there, but during the time of Y maybe some traffic were there. So we can say like non-uniform motion practically possible, and it's very common, right? So here as you can see, a person is moving 1 meter distance in 5 seconds, again 2 meter distance in 6 seconds, 7 second 3 meter distance. So here distance is not uniform, maybe the time, but distance is not uniform. So here it is very common. So this is all about your motion, like uniform motion and non-uniform motion. Let's go to the next slide. Again there is a definition, that is speed. About speed we are aware of from junior classes. So let's see what is the definition of the speed. Speed is defined as the distance traveled by an object with a particular time. Okay, here speed is depending upon the time as well. So if you will go for the formula, you can easily understand. That is, speed is equal to distance traveled by time. Okay, how much distance you are traveling divided by time that you have taken. If you will divide both the terms, then you will get the speed. Here speed is also two types. One is your uniform speed, another is your average speed. Uniform speed is what? Uniform speed you deal with uniform motion. Means same distance with same time is called uniform speed. Then average speed deals with non-uniform motion. We have already discussed about uniform motion and non-uniform motion, right? So in practical, in our day-to-day life we are facing with, or we are dealing with average speed. So what is average speed? Average speed is total distance by total time. Whatever the time interval, you need not to count. You have to go for the total distance with total time, and this is the average speed formula. In this chapter we will go for average speed always. Okay, so what sometimes in your examination they will ask, what is the unit of speed, what is the unit of displacement, what is the unit of distance. You should aware of the units. Okay, so unit is equal to, unit of speed is equal to meter per second. How meter per second? Distance can be meter, right? And the time would be second. Why I have written here meter per second? You should always you should use SI unit always. These are called SI units. Okay, standard units. So you should always go for the SI units. If in your examination they will give you distance in kilometer, you should convert that distance into meter. Okay, then you will find out your answer. So meter per second is the unit for speed. Yes, we have already discussed about scalar quantity. So speed is a scalar quantity because speed is dealing with distance. That's why speed is a scalar quantity, right? So this is all about your speed. Let's go for velocity. What is velocity? As speed is dealing with distance, your velocity is dealing with displacement, right? So velocity is also two types. First of all, we should know what is the formula for velocity. Velocity is equal to displacement divided by time. Got to know? So velocity is of two types. One is your uniform velocity, another one is your average velocity. Similarly, practically average velocity can be possible. So average velocity is equal to what? Total displacement divided by total time. As your displacement is a vector quantity, like that velocity is a vector quantity as well. Unit is same as speed. Unit of velocity is equal to meter per second. You need to know average speed always greater than or equal to average velocity. Like your distance always greater than or equal to displacement, right? Similarly, your average speed always greater than or equal to average velocity, because average speed is dealing with the distance and average velocity dealing with displacement, right? Next thing is about acceleration. Okay, acceleration is what? Acceleration can be defined as rate of change of velocity. What is rate of change of velocity? Just look at this diagram. As you can see, here is a car. Consider it is a car, okay? So here is a car. It is moving with a speed of 2 meter per second. Okay, 2 meter per second. It is moving 2 meter per second within 1 second. So this acceleration, we will discuss about acceleration by using velocity. Okay, velocity means uniform velocity. Here actually we are discussing with the uniform velocity. Okay, so as you can see, the car is moving 1 second. Here you are giving extra speed to the car. Okay, extra speed, that is 2 meter per second I have added. Again you are giving extra speed, means there is a accelerate. You can tell like accelerate the car, accelerate the bike, accelerate the scooter. So that is what you are giving the extra speed to that particular vehicle. So that extra speed is called actually acceleration. So acceleration is what? Acceleration can be defined as rate of change of velocity. Whether we will find the term rate of change, it means something divided by time. So it is rate of change of velocity, so velocity of divided by time. If it is rate of change of x, then x divided by time. Okay, so this is very easy to remember, like what is rate of change. So acceleration is nothing but it is the extra speed to the vehicle. Mathematically, acceleration is equal to change in velocity divided by time. As you can see, velocity is changing, right? So acceleration is what? Change in velocity divided by time. So how change in velocity can be defined? Like final velocity minus initial velocity. Okay, because final velocity is something, initial velocity is another thing. That's why you are telling that your acceleration is or velocity is changing. That's why you should subtract those 2 points. Okay, here final velocity denoted as v and initial velocity is denoted as u. So a is equal to v minus u divided by t. Again, that I have told you, you need to remember the units of the term. So what is the unit of acceleration? Let's calculate. Acceleration we have discussed here. Acceleration is what? Acceleration is velocity divided by time. Velocity divided by time. So what is the unit of velocity? Velocity unit is meter per second. Time is what? Second. So 1 by s. So it is meter per second square. If you are unable to remember the equation or remember the unit, then you can find out the unit in this way. Okay, so unit of acceleration is meter per second square. I think there is not any doubt from this term. There are some word problems. Those are some basic word problems that you should go through it. Just take a screenshot and try to do it yourself. Okay, with this we have completed this video. I hope this video will help you. Thank you.